Stop memorizing polar graph equations like cardioids and limicons. Two-column charts for r and theta are also overrated. Here's an easier approach. So for our first example, we're going to be looking at r equals 1 plus 2 cosine theta, except we're going to be graphing it as if we had an x and a y axis. But instead, we're going to be labeling the axes with r and theta. Now we're going to graph our equation. So when theta equals 0, r equals 3, and then it's going to hit 1 at pi over 2, and then go to negative 1 at pi, and then back to 1 at 3 pi over 2, and then 3 at 2 pi. What we're really interested in are these 2 points where the graph meets the theta axis or when r equals 0. So we can set up this equation 0 equals 1 plus 2 cosine theta, or cosine theta equals negative 1/2. So from here we can find out that theta equals 2 pi over 3 or 4 pi over 3. There's various different ways to check your answer, but the easiest way is just realize that 2 pi over 3 is in between pi over 2 and pi, and 4 pi over 3 is in between pi and 3 pi over 2. Now, how do we translate the graph on the left to the graph on the right? The graph on the right is a polar graphing chart that will help us graph our equation. The lines are the theta values. So for example, theta equals pi over 3. And the concentric circles are the r values. So for example, r equals 2, which is a circle. So first off, when theta, or the angle measure, is 0, the radius is 3 units away from the origin. So we can label this with the graph on our right. So this is when the radius is 1, then 2, and then 3. So our point will be right here. As theta goes from 0 to pi over 2, we can see the radius decreasing from 3 to 1. This means that the graph is getting closer and closer to the origin. So first we can label the point 1 comma pi over 2, which looks like this. And so we want to get from 3 comma 0 to 1 comma pi over 2 with the radius decreasing. So it's going to look something like this. Then at 2 pi over 3, we can see the r value being 0, which means that the graph hits the origin. So it's going to look like this. Then from 2 pi over 3 to pi, we see that the radius is negative. But what does it mean when the radius is negative? So a concept to understand is that a negative radius is equivalent to a positive radius with the theta value being plus or minus pi. So in this case, we can say that negative 1 comma pi is equal to 1 comma 0 or 1 comma 2 pi, however you like to think about it, because 0 and 2 pi are the same angle measure. So this just means that we want the graph to get to this green point. So we can see the radius moving further away from 0 in absolute value and reaching the point negative 1 comma pi. Then afterwards, it comes back closer to 0 and hits the origin again at the theta value of 4 pi over 3. Afterwards, from 4 pi over 3 all the way to 2 pi, we can see the radius increasing, which means that we're going to be expanding outwards again. And along the way, we're going to be hitting the point 1 comma 3 pi over 2, which is located right here. So we're expanding, hitting the point, going out, and meeting the point at the center again. So this is how the graph looks.